Hi Math, I'm Andy. Today we're going to look at some exponent rules. We're going to do the power to a power, the product to a power, and the quotient to a power. So get out your notebooks and follow along with me. We'll go over what these laws or properties are, and then I'll show you some examples of how we can use them to simplify expressions. Now, the power to a power rule, this is when you have some number, we'll call it x, and it's already raised to an exponent, we'll call it a, and this whole quantity is raised to another exponent itself. Now, the way that exponents work is you take this number and times itself this many times, and then we would do the same for this. This b is telling us to take x to the a power and times itself b times. So we have a rule for this, and how this works, to simplify this, you can just take that same base number and take the two exponents and you can multiply them. So x would be raised to the product of whatever a times b is. The product to a power rule is a little different. Now this means that we already have a product. A product is something being multiplied by something else. So let's take two numbers, x times y. And now this is going to get raised to some exponent, we'll call it a. Now the product to a power rule says that when you have things being multiplied and they're being given to an exponent itself, we can in a sense distribute that exponent. So this would have a value of x to the a power times y to the a power. And finally, the last rule we're going to look at today, the quotient to a power rule. Well, quotient means to divide, so we're going to take two numbers, let's say x and y again, and we're going to divide them, and they're both going to get raised to a power. We'll say a. Now this is going to follow similar to the product power rule, where in a sense this exponent will be distributed to both the x and the y. And so what we'll end up with is in the numerator we'll have an x to the a power and we're going to have a y to the a power. And so what we can do is we're going to utilize these three rules to simplify some different things. Now you'll notice as I simplify, you might come up with different ways or different methods to do this, but I'm just going to do it the way that I think might be best or easiest. So in the chat or perhaps with other classmates, you might want to say, hey, I did this first and then this second, and we'll notice we'll probably end up with the same thing. So let's take a look at an example such as 2x times x squared all raised to the third power. And so we can see that there's a couple of things that are going to be happening. We have our product rule in place because we have things being multiplied all raised to the same exponent, and we also have our power to a power rule happening here and secretly happening here because this is x to the first power. So what I'm going to do first is I'm going to notice that on the inside of this product that I do have things of the same base. So the first thing that I'm going to do is combine those by adding those exponents. So the 2 is still in there, nothing has happened, but this is x to the first power times x to the second power. When I add those, that's going to give me x to the third power. And we still have this thing being raised to the third power. Now, this is really a product to a power rule. 2 is being multiplied by x to the third, and they're both being raised to the third power. So I'm going to apply this rule. So what would happen is the 2 is going to get raised to the third power, and the x to the third is going to get raised to the third power. So I applied my product to a power rule. Let's do a little more simplifying. I have a power to a power rule, and so here I'm going to multiply those powers. So that 2 to the third is still going to be there, and now x to the third is really going to be 3 times 3, which is 9. So I have 2 to the third x to the ninth. Now because 2 to the third is a number, and it's something that I can actually evaluate, I'm just going to do that. 2 times 2 is 4, times 2 is 8. So 2 to the third power is equal to 8. Now x to the ninth, because we don't know what x is, we're going to leave it as x to the ninth. So in our first example, 2 times x squared all to the third power is equal to 8 x to the ninth. So you'll see all of these properties of exponents, they all kind of are going to be happening in each of these problems. So it's not just going to be a one, use this here and this here, but we're going to actually use them all. Let's try a different problem. Problem number 2, let's say, will be this. 3 to the fourth over 3 squared, all raised to the second power. So if you want to pause it and take a moment and try to solve it, and then I'll go through it and see if it matches up. Now there are a couple of things happening. I could apply my quotient to a power rule and distribute this squared to both of these. This also is a power to a power rule, so these would get multiplied. But I do see that I have a quotient of the same base, so I can subtract my exponents inside first. I always like to simplify my parentheses first. So this is going to be 3 to the fourth minus 2 power squared. So that's going to be the rule here. We subtract those exponents. That's going to give me a 3 squared on the inside of my parentheses raised to the second power. Now this is just a power to a power rule. We have 2 times 2 makes 4, so I end up with 3 to the fourth. Now remember, 3 to the fourth is really 3 times 3 times 3 times 3. So that's going to be 3 times 3 is 9, times 3 is 27, times 3 is 81. So in the end, 3 to the fourth divided by 3 squared is equal to 81. So again, you see all three of these rules kind of come into play for each of these problems. Now let's take a look at maybe just another example. Our third example, let's say, is 4x to the fourth divided by 9x raised to the third power. And I want to simplify this. Now, simplifying expressions with exponents, ultimately, we just don't want numbers that have common factors, and we don't want any negative exponents. And so when I look at this, I see that 4 and 9 don't have any common factors. And so I can't reduce that immediately. But I do see that I have x's, the same base, raised to different exponents. They're being divided, and so I can use my subtraction to simplify those. This really has a secret 1 here. This is really x to the first. And so I'm going to get a 4 in my numerator and a 9 in my denominator. And 4 minus 1 is 3. So I have x to the third. Because that's a positive, that's going to stay here in the numerator. Think of this as 4 x's up here and 1 x down here. So one of these x's would cancel with this, leaving me with x to the third in my numerator. Now this is still all getting raised to the third power. So we're going to apply the quotient to a power rule. That means that everything in here is going to get raised to the third power. So it's going to be like 4 is going to be raised to the third power. X to the third is going to be raised to the third power. And the 9 is going to be raised to the third power. So I can kind of evaluate the numbers. I know that 4 to the third power has a value of 64. This is a power to a power rule, so 3 times 3 is 9. And 9 to the third power, well, 9 times 9 is 81, and 81 times 9 is equal to 729. Now, I might just want to check if 64 and 729 have any common factors. So I'm going to use my trusty calculator to help me out with this. I might do this way. I might say 64 divided by 729. And then I'm going to use math, and then go to fractions and hit equal. And I notice that my calculator tries to take these numbers and it'll reduce it. And it looks like 64 and 729 can't reduce any less than that. So we're just going to leave our answer as 64x to the 9th over 729. So again, one of the big things that I want you to notice is that we are actually applying all three of these properties in each of these problems. And the order in which we do it can change. If I had chosen, instead of subtracting this first, but distributing the square, let's just kind of look at number 2 in an alternate fashion. So I'm just going to go number 2 in an alt fashion. So if I had 3 to the 4th over 3 to the 2nd raised to the 2nd, and I applied my power to a power rule, or the quotient to a power rule first, the 2 would get distributed here, and I would end up with 3 to the 8th over 3 to the 4th. Then I could apply that quotient rule where I subtract my exponents, and I would end up with 3 to the 8 minus 4, and 8 minus 4 is equal to 4 as well. And now notice 3 to the 4th and 3 to the 4th ends up being my final product. So just one big thing of note is that you can do these different properties in different orders and you'll still get the same result as long as you're following these specific rules. When you have a power to a power, you multiply those powers. When you have a product to a power, you can distribute the powers. And when you have a quotient to a power, you can again distribute those powers. We'll have some more problems for you to practice. Good luck, everybody.